Hello students. So we have been solving the JEE main paper of 2017 and the physics section. Please note that the code which we are referring for the entire solutions is code D, and this is question number 41 from the code D. In this question we have been given two masses. Initially a particle of mass m is moving with velocity v towards a particle of mass m by 2 which is initially at rest. The collision takes place and it's an elastic collision. After this, these two particles start moving of mass m with Va and mass m by 2 with Vb. We have been asked to find the ratio of the de Broglie wavelengths which are associated with A and B. Now, in order to find the ratio of the de Broglie wavelengths, we first need to determine what would be the final velocity of A and B after this elastic collision. So, it's a head-on elastic collision. So, we'll have to apply two things over here. First is the principle of conservation of momentum. So, initially the momentum was mv, would be nothing but equals to mass of A into velocity of A after collision plus mass of B into velocity of B after collision. So, just in order to solve this equation, I'll write mv equals to mass of A is m, Va is which we need to find out, mb is m by 2 and Vb is what we need to find out. So, this is the first equation which we generate. The second equation would be of the principle of elastic collision, that is the velocity of approach would be equals to the velocity of separation. Since it is an elastic collision, these two needs to be same. So the velocity of approach is v minus 0 and the velocity of separation would be Vb minus Va. If you solve this 1 and this equation 2, you get where Va is equals to v by 3 and your Vb is equals to 4 times v by 3. That means the velocity B, that is the particle B, is moving with a velocity 4 times more than particle A. These are the final equations of velocity. Now we need to find out what is the ratio of the de Broglie wavelengths. We know that my de Broglie wavelength associated with a particle h, is given by h is equals to p times lambda, where h is the Planck's constant, or my momentum in fact is given by h by lambda. So in this, we know that the Planck's constant for both these particles after they collide would be same. So in this scenario, my h would remain constant because it's a Planck constant. This ratio would change. That implies that Pa times lambda A, that is the de Broglie wavelength associated with the particle A, would be Pb times lambda B, that is the de Broglie wavelength associated with the particle B. Note here that Pa and Pb are nothing but the respective momentum, that is the linear momentum in this case. So if I just replace that, the mass of A into velocity of A times the de Broglie wavelength of A is equals to mass of B into velocity of B times the de Broglie wavelength of B. So in order to solve this, I need to just find out that lambda A by lambda B is nothing but equals to mass of B into velocity of B upon mass of A into velocity of A. We know that mass of B is nothing but equals to m by 2 into velocity of B, as we know, is equals to 4v by 3. And mass of A is nothing but equals to m and velocity of A is nothing but equals to v by 3. So on solving this, we get that the ratio of the de Broglie wavelengths of A to B is nothing but equals to 2. Hence, you get the ratio of the wavelength. And the principle which we used was, first, it was an elastic collision. Second, that implies that the velocity of separation was equals to velocity of approach, the principle of conservation of linear momentum. And third, that my de Broglie wavelength and momentum are associated using this formula. So I hope you were able to solve this and you were able to understand how I got to the final answer. In order to solve such questions, you need to start from the basics first. That is, to first apply the formula of linear momentum. Second, the velocity of approach is equals to velocity of separation, and then go by to the next and the final step, that is h equals to p lambda. If in case you like this video, please subscribe to our channel and please hang on to our channel as we'll be uploading more video solutions very soon.